Assalamualaikum and hello everyone, it's me again. But in this video, we're gonna learn about nuclear physics. So first, let's move on to the nuclear structure. So in nuclear, it consists of positive proton and neutral neutron. And nuclear is a collective term for proton and neutron. And the mass is 1.66 times to the 10 to the power of negative 27, and it was the mass for proton, and we have another mass for neutron and electron. And we can see here, which is A, Z and X, it was a nuclear symbol notation. A is meaning for the mass number, Z is atomic number or the number of the proton in the nucleus, and X is the symbol for the element. For the example, chlorine or helium or hydrogen, something like that. And next we going to the binding energy. So binding energy is the amount of energy to form a nucleus from its individual particle, and it was equal to the energy to split to the nucleus to its separate proton and neutron. So we can say that the binding energy is to split a nucleus into its components, and the formula involved in binding energy is this formula below. And there was a diagram here for us to make it more clear. Let's say that the X is proton and the yellow one is neutron, and when we plus with binding energy, it will separate. Okay, next we're going to the radioactivity. So isotope is an atom with same number of proton but different number of neutron, and some of them is stable and some of them is not. Unstable isotope will emit radiation spontaneously, and radiation is not good for human, right? So radioactive decay is a process in which unstable nucleus decay into more stable nucleus, and it will decay into three type particles. So first we got alpha, beta and gamma. So first we're going to talk about the alpha particle. So alpha particle is produced by helium. For the example, helium, like in this diagram here, we can see it's decaying and it's become this particle, and alpha particle is produced from the helium particle. Next, beta decay produced is beta decay produced by the negatively charged electron or positively charged positron. Like the diagram below, we can see the parent atom is decaying to the daughter and it's producing electron and antineutrino, which is beta negative and positive electron. And next we're going to the gamma decay. So gamma decay emits photon with high energy without producing any particles. Like we can see from this diagram, you can see the parent, the excited nucleus state, it's decaying, produces daughter, but there's no other particle instead of gamma ray. So that was a gamma decay. So next we move on to the radioactive decay equation. So before we have take a look on the radioactive decay, so now we're gonna take a look on the equation. So the rate of decrease in the number of nuclei in radioactive decay is expressed as A equal to negative dN per dt, and also the number of radioactive nuclei is decreasing exponentially with time. We're gonna use other formula, but in the book we use letter N instead of A. And next, the half-life equation. So half-life equation is equal to ln 2 per lambda. Yeah, it was the radioactive decay constant. Next, we move on to the nuclear reaction. So when a daughter nucleus X is bombarded by a particle A, X will change to daughter nucleus Y with emission of particle B. Like in the equation below, A plus X become Y plus D plus energy, and this reaction can be calculated using the formula below, which is Q equal to MA plus MX minus MB plus MY, and uh, we can multiply it with C squared, and we can see the S diagram beside them. This is one of the example of the nuclear reaction, which is fusion. We can see here the deuterium and tritium is fusioning. Both of them is a fast particle, and the fusion, the mass is changed after that, and the energy was produced. So I think that's all from me for this topic. Thank you very much for hearing to me and watching this video. Assalamualaikum warahmatullahi wabarakatuh. Bye bye.